I would like to start by presenting the possibility of using used cooking oil in aviation. Theoretically, it is possible, but it would require extensive processing to meet the strict quality standards for aviation fuel. In recent months, major airlines have shown promising signs by committing to realistic decarbonization targets by 2030, marking a significant stride towards a greener aviation industry, where at least 10% of our jet fuel demand could be fulfilled by using cooking oil alone.
For the design of the aircraft engines, there are two turboprop engines are fed by SAF tanks. The gearbox connects the propeller shaft not only to the engine, but also to an electric motor. The electric motors can be supported with an additional share of power during high-power flight missions like takeoff. This allows the turboprop engines to be downsized, saving mass and cost. Two more electrically driven propellers are installed at the wing. Those propellers can lead to aerodynamic improvement as they interact positively with the vortex at the wingtip, which normally induces drag.
The function of using sustainable aviation fuel is it can cut carbon dioxide emission in the race to net zero, where carbon dioxide absorbed while its organic ingredients are being grown. SUHAILI achieved to give impressive reduction up to 80% carbon emission. We can handle in the same way as the traditional jet fuel, where there are no change are required in the fueling infrastructure.
I will be focusing about the feasibility of replacing the usage of fossil fuel on aircraft by kitchen waste. First of all, the composition of kitchen waste is very complex. Kitchen waste is a non-standard resource due to its complex and varied composition based on factors such as location and eating habits. It differs from more standardized feedstocks like agricultural crops. Next, we need to consider on the cost in separating the components of kitchen waste. Processing costs may increase in separating individual components of kitchen waste like carbon and nitrogen for value-added products. This cost increase might render the process economically unfeasible.
To prove that SAF can be used as an alternative for aircraft fuel, first we have to understand how its engine is worked. An aircraft engine has a turbofan where it will push the air to the back into the core of the engine. Inside the core, it will be compressed and then mixed with the fuel before being ignited and then propel the plane. With that understanding, here is the difference between jet fuel and SAF in an aircraft. From the result we see, its performance is almost the same as jet fuel, proving it can be used in an aircraft fuel as a fuel.